In this segment, we're going to talk about apparent brightness. Apparent brightness is the brightness that a star appears to have as measured by an observer from their location, in this case from Earth. The key word here is appears, because we don't really know how bright the star really is. It's just how bright the star appears to our eyes. So let's put you on the Earth and let's let you look at the night sky and you see a bright blue star in the sky. You also see a dim red star in the sky. And you also see a not quite bright, not quite dim chartreuse color or greeny yellow colored star in the sky. To your eyes, this is how bright these stars appear. Some are bright, some are dim, or some are in between. And this is what we mean by apparent brightness. Let's compare apparent brightness with apparent visual magnitude. Apparent visual magnitude is the apparent brightness of a star as seen by an observer's eyes from their location. So here's where the word apparent brightness comes in. Apparent brightness is how bright the stars appear to your eyes, and so that's where the eyes come in. And so this is linked to the word visual, because visual means the Roy G. Biv, or the red, orange, yellow, green, blue, indigo, violet rainbow of colors which your eyes can see. You might wonder what's the difference between apparent brightness and apparent visual magnitude. Well, apparent brightness is if the stars are bright or dim, whereas apparent visual magnitude is a numerical value. So we can change our definition of apparent visual magnitude to be the numerical value of apparent brightness as seen by an observer's eyes from their location. So let's once again put you back on Earth and let you look with your eyes to a dim red star. Notice I drew it small. And a bright blue star. Notice I drew it big. Now I could have drawn the dim star as blue and the bright star as red, so I'm just assigning arbitrary colors to dim and bright at this time, because we don't know how far away these stars are, and we don't know how big these stars are. We just know that they're these colors and they're dim and they're bright in the sky. And once again, our chartreuse greeny yellow stars and in between dim and bright. So we want to assign numerical values to bright and dim. Let's say the bright blue star appears to be very bright, and so we're going to assign it a number of 0. And the dim star appears really dim, so we're going to assign it a number of 6. And so the in-between star would be something in between, and we assign it a value of 3. So on our ranking scale here, a 0 would be a bright star, and a +6 would be a dim star. And since we're talking about magnitudes, we're going to call these small m for magnitude, and because we're looking in the Roy G. Biv, or the rainbow of colors of your eyes, we're going to call it a little subscript v, indicating we're in the visual band. So this would be the apparent visual magnitude scale as seen from your eyes from the planet Earth, your location on the planet Earth. Now these are the brightness of the stars as seen from you on your location on a clear night in a dark sky. But what about the sun? Well, if we put the sun on this scale, the sun is going to be this big bright object. What number will we assign it compared to the scale that we just created from 0 to 6? Since the sun is very, very bright, it has to be brighter than the 0 star that we assigned for the bright blue star. So we have to create negative numbers in our scale. A -26 would be the sun's apparent visual magnitude relative to the scale of 0 to 6 for the stars in the night sky. So this is what we mean by apparent visual magnitude. And the scale actually extends from -30 through 0 to +30, where negative numbers are very bright objects in the sky and positive numbers are very dim objects in the sky. We will talk more about this scale when we talk about the apparent visual magnitude scale.